had a discussion about deriving the derivatives of some standard functions using first principle method. So, in the last class we derived derivative of sin x, derivative of cos x, derivative of tan x, derivative of x to the power of n. So, based on the same principle we can also find the derivative of other trigonometric functions like secant inverse x, secant x, cosecant x, cot x, log x, e power x, etc. So, let us start finding the derivative of inverse trigonometric functions using first principle method. Let us take the inverse trigonometric functions I show for 1. So, based on that we can go for other inverse trigonometric functions. Let us take y is equal to sin inverse x. The y is equal to sin inverse x is inverse trigonometric function. It is defined in the range as well as domain, that is it value varies from 1 minus 1 less than or equal to x less than or equal to plus 1 sorry y value, then the its range is minus pi by 2 less than or equal to x less than or equal to plus pi by 2. If these two conditions are verified, then we can write x is equal to sin y. If you take x value in between minus 1 to plus 1, so it occurs between minus 90 to plus 19. So, if this inverse trigonometric function satisfies these two conditions, then we can take x is equal to sin y. As x changes to x plus delta x, automatically y also changes. So, here we can call x is a function of y. So far we discussed in the last classes, there we had a y is equal to sin x. So, here we have changed the variables. As y changes to y plus delta y, then automatically x changes to x plus delta x, where delta x and delta y are increments in x and y. Therefore, x become what? X plus delta x is equal to sin of y become y plus delta y. Then what is next step? So, next step is we have to transfer this x to the right side, that is delta x is equal to sin of y plus delta y minus x. Then x is, we have to replace x by sin inverse, so sin y, x is equal to, we have taken sin y, that is replaced here, sin of y plus delta y minus x is equal to what? It is sin y. Our next step is to dividing on either side by delta y. In the last class we divided, we had a delta y is equal to something, there we have divided with delta x, here we have in delta x, therefore dividing by delta y on both sides. Therefore, delta x divided by delta y, here sin of y plus delta y minus sin y whole divided by delta y. We have to take limit, taking limit as delta x tends to delta y tends to 0 again on both sides. it become what? Limit of delta y tends to 0, delta x divided by delta y is equal to limit of delta y tends to 0 sin y plus delta y minus sin y whole divided by delta y. If you apply the limit on right hand side, we will get 0 by 0 because delta y is equal to 0, sin y remains, sin y minus sin y becomes 0, delta y become 0, therefore it will become 0 by 0 if you take direct limit. So, instead of that we have to find out the actual limit of this function by using the formula sin c minus sin d. Sin c minus sin d is equal to minus 2 cos c plus d by 2 into cos c minus d by 2. So, based on this formula, the right hand side limit become limit of delta y tends to 0 to cos c is equal to y plus delta y plus delta y plus d is equal to y whole divided by 2 into this is sin of y plus delta y minus y whole divided by 2. Here y get cancelled, whole divided by we have a delta y. This become limit of delta y tends to 0 to cos y plus y 2y plus delta y whole divided by 2 into sin of delta y divided by 2. The denominator delta y, it is whole divided by all terms at the numerator are product, therefore I can take that delta y here. To make this into standard limit, that is sin of theta by theta as limit theta tends to 0 is equal to 1. To convert this limit into the standard one, I divide by 2 for delta y and multiply by 2. So, this 2 cancel. If I apply the limit, the right hand side limit become what? Dx divided by dy, which is equal to cos of 2y, this is 0, as delta y tends to 0, this will become 0, 2y by 2, 2y divided by 2, then it will become what? 2 cancel, cos y. So, differentiation of sin y is equal to cos y. Using this we can convert into a standard for the inverse function. So, we have dx divided by dy is equal to cos y. Take the reciprocal of it, dy by cos y divided by, you assume that there is a 1. If I take reciprocal 1 divided by dx divided by dy, it will become 1 by cos y, or it will become dy divided by dx is equal to 1 divided by cos y. I will write cos y as 1 minus sin square y. So, sin y we took it as x, therefore, differentiation of this will become 1 by root of 1 minus sin y is taken as x square, because it is where y is equal to sin inverse x, therefore, x is equal to sin y. Based on this, instead of sin y we can substitute x, it is sin square y, therefore, it will become x square. It is differentiation of sin inverse x is equal to 1 divided by root of 1 minus x square. This is differentiation of sin inverse x. Differentiation of sin inverse x is 1 by root of 1 minus x square. Using same concept or using the first principle method, we can also derive the derivatives of other inverse trigonometric functions. So, that you try on own, that is differentiation of cos inverse x, we will get minus 1 by root of 1 minus x square, d by dx of tan inverse x, we will get 1 by 1 plus x square. For cot inverse x, d by dx of cot inverse x, we will get minus 1 by 1 plus x square. For sin and secant inverse and cosecant inverse, we will get d by dx of secant inverse x is equal to 1 by x into root of x square minus 1, and d by dx of cosecant inverse x is equal to minus 1 by x into root of x square minus 1. We can see for sin inverse and cos inverse, derivative is differ by only the minus sign. Different derivatives of tan inverse and cot inverse, again it is differ by only the minus sign. For secant inverse and cosecant inverse, the derivative differs by minus sign only. So, differentiation of sin inverse cos inverse is 1 by root of 1 minus x square, differentiation of tan inverse and cot inverse is 1 by 1 plus x square, differentiation of secant inverse and cosecant inverse is 1 by x into root of x square minus 1, where for cosecant inverse it will come minus, for cot inverse it will come minus, again for cos inverse it will come minus. So, these are the derivatives of inverse trigonometric functions. So, like that, using first principle method, you can find the derivative of any function. So, we have discussed only few here, that is x to the power of n, sin x, cos x, tan x and sin inverse x. You extend the same steps to get the derivative of any functions with respect to x. Now, let us discuss the rules of differentiation. Let us discuss the rules of differentiation. Rules of differentiation. These rules of differentiation we can get it by derivation method. The first principle method is extended to derive all the rules also. Let us take the first one, y is equal to k into f of x. What is k? K is any constant. K is any constant. F of x is function of x. K is constant. F of x is function of x. What the first step in first principle method says, you change x into x plus delta x, then y also changes to y plus delta y. As x changes to x plus delta x, then automatically y changes to y plus delta y. Therefore, the function become y plus delta y is equal to k into, k is function, f of x plus delta x. Next we can transfer the y to other side, delta y is equal to k into f of x plus delta x minus y. What is y? Y is equal to k into f of x. So, delta y become k into f of x plus delta x minus k into f of x. Then you can take k outside, f of x plus delta x minus f of x. You divide by delta x on both sides, divide by delta x on both sides, that is delta y divided by delta x is equal to k into f of x plus delta x minus f of x all divided by delta x. Then you take the limit on both sides, taking limit on both sides as delta x tends to 0, limit as delta x tends to 0, delta y divided by delta x, that is equal to limit of delta x tends to 0, k into f of x plus delta x minus f of x all divided by delta x. This is taken as dy divided by dx is equal to, k is constant according to property of limit, k into function, the limit is extended for the function and k is kept as it is, that is k into limit of delta x tends to 0, f of x plus delta x minus f of x all divided by delta x. In the derivative of differential coefficient, we learned that this can be taken as d by dx of function, d by dx of function, that will become k into d by dx of f of function. You can convert this into a standard limit, finally it will come into this form, d by dx of f of x. Using first principle method, you can get the answer as differentiation of constant into function can be taken as constant into d by dx of function. So, based on this rule, I will show few slides examples on this. See, when the given function is take the example, if y is equal to a into x square, where a is what? A is a numerical constant. X square is what? It is taken as a function, it is a function of x only. So, these two functions are in product, one is constant, other one is x square. You take the first term a into x square. What is a? A is a numerical constant. That numerical constant into x square. X square is function of x only. Then a is taken as it is. What is differentiation of x square? Differentiation of x square is 2x, because differentiation of x to the power of n is n into x to the power of n minus 1. Based on that, what is n? N is equal to 2. 2 into x to the power of 2 minus 1, that is a into 2x is equal to 2x only. You take the second example. What is the second example? Differentiation of 5x cube. Again 5 is numerical constant, x cube is a function. So, here 5 is taken outside. For the x cube we have differentiated. The differentiation of x cube is 3, that is n is 3, 3 into x square, that is equal to 5 into 3 is 15 x square. You see the third example, d by dx of 7 by 3 into root x. 7 by 3 is numerical constant, it is taken outside and we have differentiated root x. What is differentiation of root x? Differentiation of root x, as I mentioned earlier, differentiation of root x is taken as 1 divided by 2 root x. Therefore, 7 into 1, 7, 3 into 2, 6, that is 7 by 6 root x. You check the fourth one, differentiation of minus 5 by 4 x to the power of 4, which is equal to, constant is taken outside, minus 5 by 4 into differentiation of x to the power of 4. So, differentiation of x to the power of 4 is what? 4 into x to the power of 3, that is minus 5, 4 get cancelled, minus 5 x cube remains. See the fifth example, differentiation of 2 divided by x to the power of 5. So, 2 is taken outside. So, the function will become what? 1 by x to the power of 5. So, this is treated as 1 by x to the power of n, 1 divided by x to the power of n. One by x to the power of n, whose derivative is what? d by dx of 1 by x to the power of n is equal to minus n divided by x to the power of n plus 1. So, based on this n, what is n? N is equal to 5, that is minus n minus 5 divided by x to the power of 5 plus 1. So, 5 plus 1 is equal to 6. You see the sixth one, d by dx of 4 into sin x. 4 is what? 4 is numerical constant, it is taken outside. Differentiation of sin x. Differentiation of sin x is what? Differentiation of sin x is cos x. So, that is differentiation of constant into function. You see the next rule. The second rule is what? Derivative of sum or difference of two functions. Here we have taken two functions u and v. What is u? U is a function of x, and v is also function of x. Both u and v are taken as function of x. You go according to the first principle method. What the first principle method says, in the first step you have to take x as x plus delta x, then y as y plus delta y. According to that, when x changes to x plus delta x, y changes to y plus delta y, automatically your u and v, they are the functions of x, hence they also changes to u plus delta u and v changes to v plus delta v. All these things are substituted in the step, that is y become what? Y plus delta y. Then this u become what? U plus delta u plus or minus v become what? V plus delta v. As x changes to x plus delta x, automatically u and v also changes to u plus delta u and v plus delta v, because they are the functions of x only. Next, what I did here, I have taken u plus delta u plus or minus v plus delta v minus of y. Y is taken here. What is y? Y is equal to u plus delta v, that is substituted here. Then you multiply delta y is equal to what? This delta u plus or minus delta v. Then what is remaining? U, this plus or minus v, here minus of u plus or minus v. This plus or minus u plus or minus v, u plus or minus v get cancelled, remaining is delta u and delta v. The next step, we have to divide on both sides by delta x, and we have to take the limit as delta x tends to 0. Therefore, the left hand side become what? Limit of delta x tends to 0, delta y by delta x, and the right hand side become limit of delta x tends to 0, delta u plus or minus delta v divided by delta x. I divide this delta x for both the numerator term. This is delta u by delta x plus or minus delta v divided by delta x. According to sum or difference of limits, I can extend the limit, same limit for both sum terms or difference term. Based on the principle of finding derivatives of any function, the left hand side become what? The left hand side become dy by dx, and this will be taken as du by dx, and this is taken as dv by dx. Finally, the differentiation of u plus or minus v is equal to differentiation of u plus or minus differentiation of v. Like that, you can extend it for any number of functions. See, we have taken, instead of u plus or minus v, I have taken u plus or minus v plus or minus w plus or minus anything. You extend the above concept, that is differentiation of u plus or minus v is equal to differentiation of u plus or minus differentiation of v. The same concept is extended. You can differentiate all the terms which are in sum or difference to individually, that is du by dx plus or minus dv by dx plus or minus dw by dx plus or minus, and so on. It can be extended for any number of terms if they are in plus or minus. See the examples. First one, we have differentiation of sin x plus e power x. Sin x is taken as u, e power x is taken as u, v. So, according to the rule, some rule, we have to differentiate the sin x plus differentiation of e to e power x, that is differentiation of u plus differentiation of v. We know that differentiation of sin x is what? Differentiation of sin x is cos x. Differentiation of e power x is what? Differentiation of e power x is e power x only. You take the second example, differentiation of tan x. This tan x plus a power x. Tan x is taken as u and a is taken as v. According to the rule, differentiation of u, differentiation of u, differentiation of v. What is differentiation of tan x? Differentiation of tan x is secant square x. Differentiation of a cube is 0. A cube is 0 because a square, a cube, they are treated as constant. A square, a cube, they are all constant. You take the third example. The third example is what? 5x cube, 5x to the power of 4 plus 3x cube minus 8x square plus 9x minus 10. We have 4 terms. This is 1, this is 2, this is 3, this is 4, this is 5. Like that you can take any number of terms also. What we have to do? We have to differentiate 5x to the power of 4. We have to differentiate 3x cube. We have to differentiate 8x square. We have to differentiate 9x. We have to differentiate 10. So, all these are connected by plus or minus. According to the differentiation of x to the power of n, x to the power of n is what? N into x to the power of n minus 1. 5 is taken as it is. 5 into differentiation of x to the power of n is n into x to the power of n minus 1, that is 4x cube. Plus is there, we have carried out plus as it is. 3 is constant. This is first rule. What the first rule says? Differentiation of constant into function is constant into differentiation of first function, that is function. Here we kept 3 as it is. Differentiation of x cube. Differentiation of x cube of what? N into x to the power of n minus 1, that is 3x square, minus 8 is constant, 8 is kept as it is. Differentiation of 2 square. Differentiation of 2 square is what? It is 2x, plus 9 is kept as it is. Differentiation of x is 1. Differentiation of any constant. Differentiation of any constant is 0. Finally, 4 into 5 is 20x cube plus 3 into 3 is 9x square minus 8 into 2 16x plus 9 into 1 is 9 minus 0. This is the example. In the same way, the next rule is what? When we have product of two functions. This is called product rule. The product rule says derivative of product of two functions. We assume that the given function y is product of two functions u and v. What is u? U and v are both are functions of x only. U is also in x, v is also in x. Therefore, as x changes to x plus delta x, automatically y changes to y plus delta y. As x changes to x plus delta a, then u and v both changes to their respective increments, that is u changes to u plus delta u and v changes to v plus delta v. All these things are substituted in y is equal to u v. It become what? Y become y plus delta y is equal to u is what? U plus delta v into v. V is what? V plus delta v. Therefore, u plus delta u into v plus delta v, y is taken right side. This y is transferred to the right side, it will become minus y. Then you substitute y value. What is y value? Y value is u into v. In place of y, we have substituted u v, that is u plus delta u into v plus delta v minus of u v. You remove this bracket, see, u into v, u v plus u into delta v. U is multiplied with v, that is u v, u is multiplied with dv, that is u into delta v. At the same time, delta u is multiplied with v and delta u is multiplied with delta v. It become what? Delta u delta v. This is taken as it is, that is minus u into v, This plus uv minus uv get cancel. After cancelling this, you take delta x tends to 0, the limit on both side, and divide with delta x on both side. By applying this, it becomes what? Limit of, see, we have delta y which is divided by delta x and taking limit as delta x tends to 0. See, limit of delta y by delta x as delta x tends to 0 is equal to, what is right hand side? The right hand side is u delta v plus v delta u. For this, you use divide by delta x and take the limit. It will become limit of delta x tends to 0, u into delta v by delta x plus v into delta u divided by delta x plus delta u delta y divided by delta x. So, here we have delta v delta u, here this will become delta v only, not y, it is delta v. When we have whole divided by, we have to divide every term by delta x, no. So, according to that, we have divided each term divided by delta x. Use the limit concept. U, it is constant, we have taken outside, this is also v not u, this is also v not v, y, u into dv by dx plus v into limit. The limit is taken every term, we have extended the limit for all the terms, that is limit u into delta x tends to 0, delta v by delta x plus u into limit extended for this, limit of delta x tends to 0, delta u by delta x plus limit of delta u is taken outside, otherwise you can take delta v outside, or you apply limit for both delta u and delta v by delta x. Then as delta x tends to 0, delta u also tends to 0. So, based on this, you can write this is what? This is delta y by delta x is equal to, keep u as it is, differentiate, limit of this is what? Limit of dv by dx is equal to, limit of dv by dx is dv by dx plus keep v as it is, this is taken as delta u by delta x, this will become 0, this is 0, therefore entire thing become 0. Finally, we will be having differentiation of product of two functions. Differentiation of product of two functions is taken as, keep the first function as it is, differentiate second function, plus keep the second function as it is and differentiate the first function. That is first function into, if you consider first function into second function, that is taken like this only, d by dx dx of uv can also be taken like this, u into v dash. So what is v dash? V dash is dv by dx plus u v into u dash. What is u dash? U dash is du by dx. So based on this product rule, let us discuss one or two examples. Differentiation of e power x into sin x. So what is u? Is e power x. What is v? V is sin x. What the rule says? D by dx of u v is equal to, keep u as it is, differentiation of v divided by, plus keep v as it is, differentiate u. So based on that, v is kept as it is, u is kept as it is, or first function is kept as it is. Differentiation of v is what? Differentiation of sin x, plus keep sin x as it is, differentiation of e power x. E power x is taken as it is, differentiation of sin x is what? Differentiation of sin x is cos x, plus keep cos sin x as it is, and differentiation of e power x. Differentiation of e power x is e power x only. Therefore e power x cos x plus sin x into e power x. We have e power x common, therefore e power x is taken common, remaining is e power x into sin x plus cos x. You take the second example. The second example is what? Product of log x into cos x. Log x into cos x. You take this log x as u and cos x as v. According to the rule, you take first function as it is, log x into differentiation of second function, then keep second function as it is, u into differentiation of v plus v into differentiation of u. Log x is taken as it is. Differentiation of cos x is what? Differentiation of cos x is minus sin x, plus cos x is taken as it is. Differentiation of log x is what? 1 by x. Therefore minus log x into sin x plus cos x into 1 by x. Because of plus sign I have taken, this is first, cos x divided by x minus of this, minus of log x into sin x. You take third example, y is equal to x into sin inverse x. X is taken as u and y is taken as v. This is u, and this is v. You just extend this to the product rule, u into differentiation of v plus v into differentiation of u. So x is kept as it is. Differentiation of sin inverse x is what? Differentiation of sin inverse x is 1 by root of 1 minus x square. Then b is to be kept as it is, that is sin inverse x is taken as it is. Differentiation of v is what? X. Differentiation of x is what? 1. Finally it become what? X into 1 x divided by root of 1 minus x square plus 1 into sin inverse x is sin inverse x. You take the fourth example, y is equal to x square plus x into e power x. Here we have sum of two functions, that is x square plus x into e power x. Inside the sum we can find product of two functions. Directly we should not take product rule for this. First it is taken as sum rule. It is taken as sum rule. U plus v. So differentiation of u plus differentiation of v, that is sum rule. Differentiation of x square is what? Differentiation of x square is 2x. Then differentiation of x e power x, here again it is considered as u into v, u into v, product rule. Take differentiation of x square as 2x, we have a plus, plus is taken here, this is taken again u into v. Sometime both sum rule difference rule combines, or sum difference and product rule combines, we have to apply according to the rule only. So this is differentiated by using product rule, that is u into v. Keep u into differentiation of v plus v into differentiation of u. Differentiation of e power x is what? E power x plus e power x is taken as it is. Differentiation of x is what? Differentiation of x is equal to 1. Therefore 1 into e power x is e power x. You can write e power x is taken common, otherwise you can keep as it is, that is equal to 2x plus, you can take e power x common, remaining is x plus 1. The last rule, the last rule is what? Quotient rule. What is meaning of quotient? One function by another function, or one quantity by another quantity. You take y is equal to u divided by v. What is u and v? U and v are the functions of x only. According to first principle rule, we have to increment both x and y. As x is incremented to x plus delta x, then y automatically incremented to delta y. As x become delta x plus delta x, automatically y become y plus delta y. As x changes to x plus delta x, automatically y changes to y plus u plus delta u, and v changes to v plus delta v. We have applied for both. See, y is equal to what? Y plus delta y is equal to u divided by v. U become what? U plus delta u. V become what? V plus delta v. That is equal to, y is transferred to the right side, then it will become what? Minus y. You substitute y value. What is y value? Y value is equal to u divided by v. That is substituted here. See, y is equal to what? U by v. Delta y is equal to u, delta u plus delta u by v plus delta v minus u by v. Take LCM. The denominator are different terms, their product will become LCM, that is v plus delta v into v. The numerator becomes product of numerator of first into denominator of second, that is v into u plus delta u minus u into v plus delta v. Multiply it, u into v, u into v, uv, then v into delta u minus u into v, then u into delta v, divided by, multiply this, v into v square, v into delta v, these two get cancelled, that is uv and minus uv get cancelled. Remaining is what? V into delta u minus u into delta v whole divided by v square plus v into delta v. On dividing both side by delta x and take the limit as delta x tends to 0, then it will become what? Delta y by delta x as limit delta x tends to 0. Right side also the whole thing applied limit as delta x tends to 0 whole divided by delta x. As we know that x divided by y whole divided by z become what? X divided by y into z, because this z goes to numerator. So, based on this concept, here we have taken this delta x to here, then it is divided for both delta u and delta v, that is v into delta u by this delta x minus u into delta v by delta x whole divided by v square plus v into delta v. We have extended limit for both. See, this limit is extended for this and this limit is extended for this and this limit is extended for this also. For both numerator and denominator we have extended the given limit. For every term we have taken the limit. See, v into du by dx minus u into dv by dx whole divided by v square plus v into delta v. As we know that if delta is equal to 0, automatically delta v is also equal to 0, delta x tends to 0, delta v tends to 0 and delta u also tends to 0. If you apply that dy by dx, this is differential coefficient, we have to take it as delta y by delta x, v into, this is taken as what? This is taken as du by dx minus u into, this is taken as dv by dx whole divided by v square will be there, delta v is what? Delta v is 0. When this is 0, v into delta v is also 0, therefore v remains v square. So, the quotient rule is what? Differentiation of u by v is equal to v into du by dx minus u into dv by dx whole divided by v square. You just correlate both product rule and quotient rule. In product rule we have only first term into differentiation of second plus second term into differentiation of first term, but in quotient rule we have starts with v, that is v into du by dx. Here at the middle we should have a minus sign, then u into dv by dx. At the denominator we have to take v square. You see one or two examples. Y is equal to sin x divided by x square. Sin x is taken u, x square is taken v. What the rule says? U into differentiation of u minus u into differentiation of v divided by v square. Here what is u? U is sin x. What is v? V is x square. According to that we have substituted here. V is what? X square, differentiation of sin x minus sin x into differentiation of v. V is x square divided by x square whole square. This x square is kept as it is. Differentiation of sin x is what? Differentiation of sin x is cos x, minus we have to keep sin x as it is. Differentiation of x square, differentiation of x square is what? 2x, x square 2 whole power 2 is become x to the power of 4, then x square into cos x minus 2x into sin x divided by x to the power of 4. See, y is equal to a square minus x square divided by a square plus x square. The whole thing whatever is given at the numerator is taken as u. the denominator what they will be given is taken as v. This is u, this is v, according to the rule u into v into differentiation of u minus u into differentiation of v whole divided by v square, whole divided by v square. Just we have applied according to that. Keep v as it is, differentiation of constant is 0 minus differentiation of x square is 2x minus keep v as it is, differentiation of a square is 0, x square is 2x. So, if you leave 0, we have to multiply with minus 2x, we will get minus 2x into a square minus 2x into x square and 2x with minus a square, 2x with minus of minus plus a square. These two get cancelled and remaining is what? Minus 2 plus 2 4 ax square divided by x square plus x square a square plus x square whole to the power of 2. That is the example for quotient rule. So, this class we have discussed the rules of differentiation, that is sum rule, product rule and quotient rule. Based on that I have given 1 or 2 examples. In the next class let us discuss the problems based on all the rules of differentiation. So, with this I conclude today's class. Thank you very much.